5 comma negative 6. So this is all you need to know about translation. And when it comes to translation, I am just talking about left, right, up or down. So let's see some more transformations. So stretch means an object is stretched either vertically, horizontally, or both ways. We'll talk separately each one of them. So when a stretch is happening, there is to be a scale factor involved. So for example, if I say 2 times f of x, now this means that stretch vertically elongated curve with a scale factor of 2. So this number is the multiplier here. So f of x, which was initially like this, which was initially x plus 2 whole squared times x minus 4, after a multiplier effect of f of x 2 times, this is going to be 2 times x plus 2 whole squared times x minus 4. The key factor is y coordinate. Since it's stretching vertically, y coordinate is multiplied with, in this case, 2. So as you could see here in this curve, this coordinate here is negative 4 comma negative 6 and the y coordinate is negative 6. If you multiply negative 6 with 2, this will become negative 12. So the point, let's assume, I don't have much of a grid here though, but this point reaches here and this point is called negative 4 comma negative 12 after a multiplier effect of 2. This coordinate b is negative 2 comma 0. So if I multiply 0 with 2, it remains as is, though there won't be any difference here. So this point here, C, which was 0 comma negative 3 after the impact, will actually reach a point with somewhere this, and negative 0 comma negative 6. This point here will be as well elongated, but this is not marked anywhere, so we'll roughly try to take it somewhere here. And this point here, D, won't have any impact either because its y coordinate is 0. Let's join all of these dots. I'll erase the rest of the dots here, the ones that are not needed. So now once after joining these, you will see the curve may look like this. So this is the elongated part. So if I say half of f of x, so again it's a vertical stretch with a scale factor of half, so which means every y coordinate is going to be multiplied with half. So the equation here in this case is going to be f of x, which was initially x plus 2 whole squared times x minus 4, is now 1 over 2 times f of x is going to be as same as 1 over 2 x plus 2 whole squared times x minus 4. So the impact on D and B won't take much of a place, but this coordinate here is going to be somewhere here and will be 0 comma negative 3 over 2. So this point here 4 comma negative 6 will be multiplied. So negative 6 times with 1 over 2 gives you a coordinate negative 4 comma negative 3. So the effect of it will look like this. Something like this. So the coordinates, these are the only coordinates changing, and you will get to see apart from others, but all the points that are touching the x-axis which have their y coordinates 0, they won't create any impact. So let's see another stretch. So if I say f of 2x, now this means that this is a horizontal stretch, and the scale factor in this case is 1 over 2. Now, do you remember that 2 times f of x, when I was vertically multiplying, we had a scale factor of 2, but here we have a scale factor of 1 over 2 when if it is inside 2x. You will get to visualize this when you will study sine curves, and you can refer to my sketching video related to the sine function to get a clear idea. When sine of x becomes sine 2x, so in that limited space, the curve will have two waves where it had normally one wave. So let's look at this one. If I have to write the syntax in this case, which was f of x initially, now if I say f of 2x, so this means instead of x I replace it with 2x plus 2 whole squared, 2x minus 4. You can further solve it though, but here when it's a horizontal stretch, as you could see, let's say this is a wave. Within this space there are two waves. Let's say if I say, so it's a shrink effect within the x-axis, and if I say x-axis, so which means x coordinate is going to be changing here. So point A will be lying somewhere here now, this point, which is now A, and you can write this as negative 2 comma negative 6. Point B, which was at negative 2 comma 0, so negative 2 divided by 2 gives you negative 1 comma 0. So this is where point B lies. C remains at 0 comma negative 3 because the x coordinate was 0, and 0 divided by 2 gives you 0. So this remains as is. So this coordinate here will shrink further, and this coordinate D, which is 4, is going to be somewhere at 2, half of it. So the curve will look like this. So it's shrinking on the x-axis. It's not translating. If you see the translation when it happens, when the object was moving to the left, all of the curve is moving to the left or right. But here, as you could see, it's enclosing, so shrinking this both ways. Now, looking at f of 1 over 2x, this as well is a horizontal stretch. With a scale factor of 2. Now, scale factor, as we agreed upon, that this value here divides, so divided by 1 over 2 makes it 2. So you multiply it with 2. Every x coordinate is going to be multiplied with 2 now. So it's going to be elongated on the x-axis. It's a horizontal stretch. Now, writing down the coordinates here. So a, which is at negative 4 comma negative 6, so the x coordinate here is negative 4. Multiply it with 2 gives you negative 8 comma negative 6. So somewhere here, just assuming this is our a point, b is going to be negative 2 comma 0, so which will eventually be times with 2, negative 4, just assuming it is negative 4 comma 0, and this is b. Now this is a, which is now negative 8 comma negative 6. C, which was 0 comma negative 3, remains there because x coordinate times with 2 takes it 0. So 4 times with 2, which is going to be 8 comma 0. Now sketching it again, so which means so it's going to be something like this. As you can see, it is stretched on the horizontal axis. So the equation here, f of x, which was x plus 2 whole squared times x minus 4, is now going to be, after the impact of 1 over 2x, this is going to be 1 over 2x plus 2 whole squared times with 1 over 2x minus 4. So this is all you need to know about stretching. Now let's look at our third and the last part of it, reflections. So if I say negative f of x, now this means that the curve is reflected, and when we talk about reflection, we talk about mirror lines. Without mirror explaining or writing down the mirror line, there is no concept of reflection that you are required to answer. So reflection, when I say reflection, the line x-axis, or we also call y equals to 0. So this is the mirror line here. I'll try to highlight that. This is the mirror line now. You have to draw a reflection of that graph. So first step, since f of x was equals to x plus 2 whole square times x minus 4, negative f of x will be negative x plus 2 whole square times with x minus 4. And negative, so remember that negative of any curve that you draw will always be a reflection in the line y equals to 0 or the x-axis. If I draw this curve, a reflection will look like this. the points that were mentioned, as you could see, that as the point touches the mirror line, so these points B and D remains as they were, but rest of the point C is now going to be here and 0 comma positive 3 now. Same as for A becomes negative 4 comma positive 6. So in this we multiply the y coordinate with -1, or in other words we just change their signs. Then comes f of minus x. This is a reflection and on the line y-axis, or x is equals to 0. So let me draw the line first. So this is my mirror line now, and if I have to draw the same curve, it will look like this. So the point A, which was here initially, is going to be now this point, and so obviously as I can see that the x coordinate, which was negative 4, and y coordinate, which was negative 6, y coordinates remain, but x becomes positive 4 comma 6. So this point remains as same. This point here is B now 2 comma 0, and point D is now going to be negative 4 comma 0. This is how the reflection looks like. In order to write it, f of x, so it was x plus 2 or squared x minus 4, f of minus x will look like negative x plus 2, replacing x with negative x minus 4. Third part is f of x. We call this modulus or absolute value functions. So absolute value, what does is that it converts negative of a function and reflects it graphically, although mathematically it converts into positive. But how? So it reflects the negative of a function only and reflects it completely on the line x-axis or y equals to 0. So there is a reflection here, but very selective reflection, and that is going to be in the line y equals to 0 x-axis, but it is only limit to negative of a function. So as you could see, this is the negative completely below the x-axis. This is my negative function. I just have to reflect it over on the line. So the mirror line, keeping x-axis in mind, now the reflection will look like this. And this point, that's it. Note that this part of the curve is already positive. We don't do much about it. It remains as is. So the point which was 0 comma negative 3 becomes 0 comma 3, and the point which was at negative 4 comma negative 6 becomes negative 4 comma positive 6 after reflecting. You just have to write f of x, which was x plus 2 whole squared times x minus 4. So this will become modulus of x plus 2 whole squared x minus 4. That's it. So this is all about reflection. So in today's lesson, we talked about transformations related to stretch, translations, and reflections. So if we have to summarize and write our rules, we can write it like this. So if it is f of x plus a, this means that the function is translating a units up. Now, a could be any number. Since I was using 1, 2, 3, any constant values, a will be constant values and will be given to you in the questions. So a has to be a constant value. Then f of x minus a, this is translation a units down. F of x minus a in the bracket gives you translation a units right. And similarly, f of x plus a means the curve is translating a units left. We already have discussed what happens to their coordinates. So if I say a times f of x, it is stretch vertically with scale factor, I'm writing as f instead of scale factor, of a. If I say f times ax, this means stretch horizontally with scale factor of 1 over a. Now, negative f of x, this is reflection in the line y equals to 0. We also write x-axis. F of minus x inside means reflection in the line x is equals to 0 or y-axis. So modulus of f of x means reflection in the line y equals to 0 but negative part of the graph. So this is all about transition of a function. These are the transformation that you need to know, and you can yourself test that wherever you draw trigonometric, exponentials, logarithmic, and arithmetic functions. So rather than remembering each of one of their own dynamics, you just need to remember their parent function. And I will do my next session on those parent functions as well. But just remembering those parent functions and transitioning them from one place to another by just keeping these rules in your head and applying them in their equations, it becomes so easy to understand this way. I tried my level best to make you understand how it works, but if you have any suggestions, comments, you can write them down. Until then, take care. Bye.